In this video, we will be discussing moles. We will start with explanations, then look into a couple different examples. A mole is a unit that allows chemists to count atoms, molecules, or ions in a substance, even though we can't see them individually. This is because these particles are extremely small, making them hard to work with one at a time. Think of a mole like a chemist's dozen, only instead of 12, a mole represents a much larger number. 1 mole of any substance contains exactly 6.022 times 10 to the 23rd power particles. This value, called Avogadro's number, is a constant. It's very large, which makes it easier for chemists to measure small particles in large quantities. For example, 1 mole of water has 6.022 times 10 to the 23rd molecules in it. So why is this useful? In chemistry, reactions depend on specific ratios of molecules or atoms, but we can't work in individual particles, they're just too small. By using moles, we scale up the number of particles to a manageable level, letting us work with grams instead of individual atoms. Molar mass links the concept of moles to a measurable quantity. Molar mass for any element or compound can be found on the periodic table as the atomic or molecular weight. We use grams per mole to signify how many grams of an element are in 1 mole. For instance, the molar mass of water is 18 grams per mole. This means that 1 mole of water weighs 18 grams. Let's go through a simple calculation. To find the number of moles in a substance, we use the formula mass times 1 over the molar mass, or mass divided by molar mass. In our first example, if you have 36 grams of water, and we know water's molar mass is 18 grams per mole, you would divide the mass, 36 grams, by the molar mass, 18 grams per mole, and be left with 2 moles of water. Let's look at glucose, a larger molecule with the formula C6H12O6. Suppose you have 90 grams of glucose and you want to find out how many moles that represents. First, we calculate the molar mass of glucose by adding the atomic masses of each element in the molecule. Glucose contains 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Let's break it down. For carbon, we have 6 of them in our formula times 12 grams per mole, giving us a total of 72 grams per mole just for carbon. For hydrogen, we have 12 of them times 1 gram per mole, giving us a total of 12 grams per mole. We have 6 oxygen times 16 grams per mole for each oxygen, giving us a total of 96 grams per mole. Adding these up, we get a total of 180 grams per mole for glucose. Now we use our formula to calculate how many moles we have. Remember, it's mass divided by molar mass. So the mass that we're looking at in this problem is 90 grams. So we're going to divide 90 grams by the molar mass that we found was 180 grams per mole, leaving us with 0.5 or half of a mole of glucose. Our next example is going to be calculating the moles of acetylsalicylic acid, or aspirin, which has the chemical formula C9H8O4. Suppose we have 200 grams of aspirin. We want to calculate the number of moles. First, we need to find the molar mass of aspirin. We have 9 carbon atoms with 12 grams per mole per atom, giving us a total of 108 grams per mole. We have 8 hydrogen at 1 gram per mole, giving us 8 grams per mole. And we have 4 oxygen atoms at 16 grams per mole, giving us 64 grams per mole. Adding them together, we get 180 grams per mole. Now looking at our equation, again, we have to do mass divided by molar mass. We have a mass of 200 grams, and we want to divide by the molar mass, which we found to be 180 grams per mole. Doing this division gives us a total of 1.11 moles of aspirin. So 200 grams of aspirin is approximately 1.11 moles of aspirin. Now, let's look at mole-to-mole ratios. Let's look at a synthesis of ammonia, NH3, from nitrogen, N2, and hydrogen, H2. The balanced equation is N2 plus 3H2 yields 2NH3. Suppose you have 4 moles of H2 and want to know how many moles of NH3 can be produced. From the equation, you can see that 3 moles of H2 produces 2 moles of NH3. Using this ratio, we can multiply the 4 moles of H2 by the ratio, ensuring that hydrogen is on the bottom so they can cancel out and we're left with moles of NH3, to get 2.67 moles of NH3. So 4 moles of hydrogen will produce 2.67 moles of ammonia. Let's look at another mole-to-mole example, the combustion of methane, or CH4. The balanced chemical equation is CH4 plus 2O2 yields CO2 plus 2 H2O. Suppose you have 3 moles of methane, or CH4, and want to find out how many moles of H2O, or water, this will produce. From the equation, we can see that for every 1 mole of CH4, 2 moles of H2O are produced. Using this 1:2 ratio, we can set up the proportion. We can multiply 3 moles of CH4 times the ratio, ensuring that CH4 is on the bottom so they cancel out, leaving us with moles of H2O, giving us a total of 6 moles of H2O. So 3 moles of methane will produce 6 moles of water. Now let's look at a mole to gram example. Let's say we have 0.75 moles of sodium chloride, NaCl, and want to know the mass in grams. To find this, we use the molar mass of NaCl. Sodium, Na, has a molar mass of approximately 23 grams per mole, and chlorine, Cl, has a molar mass of approximately 35.5 grams per mole, giving us a total of about 58.5 grams per mole. Now to find how many grams this is, we'll multiply the number of moles that we have by the molar mass. So in this case, we'll do 0.75 moles times 58.5 grams per mole, leaving us with 43.88 grams. Doing this multiplication will cancel out the moles, leaving us with just the grams. So 0.75 moles of NaCl is approximately 43.88 grams. Let's look at another mole to gram conversion, this time for calcium carbonate, or CaCO3. Suppose we have 1.2 moles of calcium carbonate and want to know the mass in grams. Again, the first step is to calculate the molar mass of CaCO3. Calcium is 40 grams per mole, carbon is 12 grams per mole, and we have 3 oxygen at 16 grams per mole, giving us 48 grams per mole total. If we add all these values up, we're left with 100 grams per mole for this compound. Now we calculate grams from moles. Again, we're going to multiply the amount of moles that we have by the molar mass, which is grams per mole, leaving us with 120 grams, meaning that 1.2 moles of calcium carbonate is 120 grams. To recap this video, we first went over what a mole is. A mole is a unit in chemistry used to count atoms, molecules, or ions by scaling up tiny particles to a measurable quantity. 1 mole of any substance is 6.022 times 10 to the 23 particles, also known as Avogadro's number. We also looked at molar mass, which is the mass of 1 mole of a substance, usually expressed in grams per mole. It's calculated by adding the atomic masses of all the atoms in a molecule. These atomic masses can also be found on the periodic table. We looked at mole to mass and mass to mole calculations. To convert between moles and grams, we use the formula moles is equal to mass in grams divided by the molar mass, which is in grams per mole. Conversely, to convert moles to grams, we simply multiply the number of moles by the molar mass. So the mass is equal to moles times molar mass. We also looked at mole to mole conversions, which are derived from balanced chemical equations and indicate the proportions of reactants and products. Thank you for watching.